All right, so we're we're almost at the end of completing all of our notes for this term. So if you guys were to look at your classroom, you would see that you have all of your notes that are already posted. We would have looked at 1.9 last week, user interface. So that means by today, you should have completed writing 1.9. Today we'll be starting 1.10. So that means you have until next week. And then 1.11, you will be printing that one if you can print it. So you're allowed to print that one. So the last notes you're writing is 1.10. And then after next week's class, then I will tell you about creating your video. You guys can see my screen, right?
Yes, sir.
All right. So, as I mentioned, this is our second to last topic that we'll be looking at. Types of computers. So, in today's day and age, there are different types of computers that are used for different purposes. So, as a student, you might need a certain type of computer compared to, say, for instance, a traffic light. That won't use, say, for instance, you as a student to do your homework, to do your assignment, you need a laptop. Now, a traffic light, does it need a laptop in order to change the colors on the light? No, it doesn't. So, the point is, in each situation that a computer is needed, a different type of computer will be used. There might be specially designed for the task, or it might be a general computer, but just that it has different parts inside of it. So today, we will be looking at the types of computers and what you will use in the different situations. So, our first paragraph, let's see who will be reading for us today. Um, Akhilesh, you can read for us. Akhilesh?
We need computers. We need computer systems in almost every aspect of human life, from preparing meals to maintaining cars and traveling to work or school. For example, a control system uses machines to accept input as instructions, produce outputs such as changing the red, amber, and green of traffic lights or moving a robot arm to packet X. A communication system usually transports data through the network from one point to another. Computer information system is responsible for the collection of data, its processing information, and the overall management and distribution of information.
Good. You can pause there. So, as I mentioned before, to carry out different tasks, you would make use of a computer system. And these computer systems, the developer would design the computer system to suit the need. So, for example, um, the traffic light system, as I mentioned, it won't be a large computer, or it won't need a screen for you to see what you're doing on the computer, like how you're looking at your phone or how you're looking at a desktop or a laptop. So, depending on the situation, depending on the need, you would the developer would design the computer system to match that need. Now, even a robot that is used to um, a robot that is used to, it says, pack eggs. So, for instance, robots that are used to carry out tasks um, like those in a factory where you have a line process of maybe creating flakes, cereals. So each machine would carry out its task of doing its part. A computer system controls that entire machine, and its design would be different compared to the computer system that you're using right now. Let's see. Amelie, you can read for us.
Computers and communication devices can therefore manage large amounts of information at a faster rate than manual systems, such as filing, sorting, and labeling. When choosing a computer information system for a particular application, you need to consider what hardware is used, such as input, storage, and output devices. What software is used, including product customization, general purpose, and specialized software. What processing takes place, what human computer interface is used, which people are involved and what work they do, and what data is required.
Good. You can pause there. So, in today's age, we have tasks that we need to carry out. For example, a clerk that is working in an office, she would have to prepare documents. Say, for example, the secretary that is inside of that works in the school in the office, she has to prepare documents for the school. She has to prepare documents for you, the students, for teachers, and so on. Now, instead of manually preparing those documents, writing those documents, and filing those documents in a cabinet and so on, companies can make use of computer systems so that they can carry out those tasks much faster. So, it's the same with other needs. For example, a factory that is producing cereals. Instead, give me a second. Yes. Say, for example, you have a factory that is used to produce cereal. Now, a manual workforce would be persons doing all of the packaging, doing all of the mixing, the preparation, and so on. But today's age, we have computer systems, we have robots that are controlled by computer systems that can make those tasks easier, can make them simpler, can make them faster. So, in any given situation, there is some sort of computer system that we can make use of to make tasks easier. But in each situation, the computer system might look different, but they all operate basically the same way because, in essence, they're still computers. So, as we would have learned so far, When, as the first line here says, when choosing a computer information system for particular application, so whether that be in a factory or if you're in an office, you still need to consider all of these factors here. So no matter what computer system is being used for any situation, you still need hardware. So the first question that developer is going to ask, what kind of hardware do I need? What kind of input device do I need? What kind of storage device do I need? What kind of output device do I need? Because the computer system, even though it is being used in a factory, it still is carrying out these three main tasks: input, storage, and output. Now, after you decided what hardware you're going to use, you also need to decide what software you're going to use. So, we recently looked at the different types of software. We looked at custom written, we looked at general purpose, and specialized. Now, in each given situation, there might be different softwares that are needed. So, for example, if, say, for instance, someone working in the office, what type of software would they need? This is a question for you guys. We have the types of software there: custom written, general purpose, and specialized. A person working in an office, what type of software do you think they would need? Anyone? Or should I call someone? Keslin, what type of software would someone in the office make use of? Custom written, general, or specialized?
Sir, please repeat the question.
What type of software would a person in an office need to use or would make use of? Custom written,
Sir,
gen-
sir, general purpose.
any reason as to why you would say general purpose?
Mm, me no. Um,
Can you remember the difference between general purpose and custom written and so on?
no, sir.
Anyone can help her out because she's heading in the right direction.
So specialize.
So you're telling me someone in the office would use specialized software?
Yeah.
Okay. Well, actually, Keslin answer was correct. General purpose is used mostly, if you look back at your notes, general purpose are used by the majority of persons. So, a person working in the office, they're going to be doing common tasks that everyday persons would be doing. So, those persons would need general purpose software. Now, contrast that now with a factory that has a robot that is doing the packaging, that is doing the preparation, and so on. What type of software would that um, computer system for that robot need? Varshini? Varshini, what do you think? Seems Varshini is hiding. Saskia, what do you think?
There was the question.
So we're contrasting now with a factory. A factory that is using a robot. So and the computer system is controlling that robot. Which one of these types of software would you think that computer system would use?
Sir, if you're not responding, my internet is not working properly.
Okay. You want to try now?
What was the question?
Which one of the types of software do you think a factory would make use of?
Um,
I'll give you a hint. If general purpose is used by everyday persons, and a factory is not used by everyday persons, so what type of software would it make use of?
Specialized.
Specialized? It could be specialized, and it could also, but it's mostly custom written. So the company now would customize their own software and build it from scratch so that they can control whatever system they have in place. Alright, let's continue. So after we determine the hardware, the software that we need to know what kind of processing needs to take place. So we looked at processing a while ago, the different types of processing. Do we need to process all the data at once? Do we need to process it right away? So that is how you would set up your processing. Then what human computer interface is used? This would go back to hardware. Which people are involved, what work they do, how they would interact with it, and so on, and what data is required. How are they getting this data, and so on. So all computers basically have these same factors, but just that they will be different based on the needs. All right. Amina, could you read the next paragraph for us?
The first four points were discussed earlier in this chapter. You can now apply this knowledge to decide which systems and applications are appropriate in various computer-related fields based on their input, processing, storage, and output needs.
Good. So I hope you guys are actually seeing the connection. That everything you would have learned so far, you're building upon it. You learned about the different parts of the computers, the hardware, the software, the input device, the output device, how it does the processing, the memory, and so on. And so that now you can put all of this together so that you can know what devices can be used for different situations. But it seems some of you can't remember anything. So let's continue. We're now getting into the types of computers. And Crystal Simon, I saw Dan earlier. I'm not seeing her anymore. Crystal Simon, you can read for us types of computers.
Types of computer system. Computer information system can be chosen to suit different users and tasks. They also classified by the processing speed, storage, and probability.
Mainframe.
Mainframe. The term mainframe is originally referred to the cabinet containing the CPU or main. Mainframes are very large. Mainframes are very large capacity computers with several CPUs capable of supporting hundreds or even thousands of users. Those such as IBM Z Enterprise
Did
mainframe
you
are
just skip
built
that
with
word?
spare components. Which one?
Simultaneously.
No.
Okay, continue. Continue.
Mainframe are built with spare components to prevent breakdowns. Data flow between users and
Peripherals.
so where am I? I can't really see.
Data flow between peripherals.
Data flow between peripherals and communication devices. Users may not be connected to the mainframe remotely, and the only system administrators will have direct access to the physical computer. Primary and secondary storage are therefore extremely large. Organizations such as banks, airlines, and universities and governments departments use mainframes. They are very expensive to buy, and they need full-time staff for their operations, maintenance, and upgrades.
Good. So, before we get into mainframe, the first paragraph here is telling us that the types of computers are classified based on their processing speed, their storage, and their portability. So, how much data it can be, how much data it can process, how much data it can store, and how portable is the computer system. All of that will determine what category basically it would fall under. So the first type of computer system we'll be looking at is the mainframe computer. So we'll be looking at it in parts again. Now, there's different advantages and disadvantages, so I hope you guys take note of them. So the term mainframe actually refers to the cabinet that contains the CPU, or basically the computer. Now, mainframes are very large computers and they have several CPUs inside of them. So, because of that, they are capable of supporting hundreds or even thousands of users. I think um, we looked at this before in a topic. I think it was, what was it? Was it application? I can't remember which topic it was, but we looked at it in a topic whereby multiple users can connect to one device. So this here is the device that those multiple users connect to. It is the mainframe, also called the server, and these hundreds or even thousands of users connect at the same time, and the mainframe computer to them is like if each person has is connecting to their own computer, whereas they're actually only connecting to one large computer. But the computer, the mainframe, has so much power, it makes it seem as though it is multiple computers to the user. Now, these mainframe computers, they are built with spare components inside of them because remember they are supporting hundreds and thousands of users. So that's a single point of error there. If the mainframe goes down, then all of the users will not be able to access any work or carry out any tasks that they need to do. So these servers, they allow spare parts or spare components so that's why it has multiple CPU, it will have multiple hard drives, it will have multiple RAM, it will have multiple power supply, and so on. So if one goes bad, the other one will continue to make it work until the one that is not working can be replaced. Now, unlike a normal computer like you have right now, a laptop or a desktop, mainframe computers are accessed remotely. So the mainframe computer might be in its own building, and you don't have to physically go to the mainframe computer in order to do work on it. You can connect to the mainframe computer remotely to carry out your work. And that is what most users would do. But obviously, if anything goes wrong, then you would have to physically go to the mainframe computer. So only the administrators would have direct access to the physical computer. Now, with a mainframe computer, the primary and the secondary storage are extremely large because we are supporting large amounts of users. So, can anyone remember what is primary and secondary storage? Robert, can you remember?
Not sure, sir.
Jonathan,
Sir, one is used to hold data long term.
Sir, primary secondary storage is like the physical flash drive or SD card,
good. So is that
and
Their
primary
primary
storage is like
primary storage
RAM and
uses
ROM.
main memory, while
RAM,
the secondary storage saves programs and data permanently.
good? So that's exactly it. The primary is the temporary storage or the RAM inside of your computer. So it needs that in large amount because remember, your computer needs the RAM in order to function properly. So if we have many users, that means we need a lot of primary memory to support all of those users as they open all of their applications and do their work. And also we need a lot of secondary storage, which is the permanent storage for when these users have completed their tasks. Now, organizations that make use of mainframes, they would include banks, airlines, universities, government departments, and so on. Mainframes are very expensive. That is why only large companies would make use of them. And not only are they expensive, but they're also high maintenance. So you need an entire staff to actually maintain, operate, and upgrade a mainframe. So basically, only large companies and organizations would make use of a mainframe because they have multiple, many, not multiple, many users. So let me see if we have an example of a mainframe. No example of a mainframe. Right. So these here are examples of mainframe. See, they look nothing like a normal computer. They have no screen, no no keyboard, no mouse, because we don't connect to them physically where they are. We mostly connect to them remotely to do any work. So the first part in the notes had said that the mainframe refers to the cabinet. So notice it's like if you're seeing cabinets, but if you look closely, these rectangles that you're seeing are the actual computers inside of the cabinet, the mainframe. Let me see. Google mainframe. And this is an example of an entire building that is being used to house a mainframe computer. So all of these are computers, mainframe computers, that would serve many users. I think, yeah, I think that's Google's mainframe. Hopefully it is. All right, so the next type of computer are the common computers that you guys know about, the desktop systems. So let's see, Jonathan, you can read for us.
Desktop systems, also simply called a computer, a personal computer or desktop system, fits on an office desk. It is easy to buy, upgrade, and maintain. Its tasks are for a single user. Memory sizes are increasing, but it is not uncommon to find primary storage sizes of 8 GB RAM and hard disk sizes of 1 terabyte. Most computers now contain multiple processors, CPUs, working at speeds of 3 gigahertz. Their main use is for office and schoolwork, games and entertainment, internet access and data communication, including email.
All right, so the common desktop computer that you guys make use of. So that is a type of computer that would be make use of in everyday situation. Whether you're a student, whether you are a worker, or you work in an office, you would make use of this common computer system. Now, the desktop is also called a personal computer because at most cases, it's only one person making use of it at a time. So that's why it would be considered a personal computer. So it usually fits on an office desk, whereas a mainframe computer would need an entire building. So you can see the difference there in size. Now, it is easy to buy as compared, easy to buy, upgrade, and maintain as contrasting with the mainframe, which is expensive and has high maintenance. Now, a single user would mostly make use of a desktop. The memory sizes, you can say it's very small compared to a mainframe because you don't have so much tasks to be carried out, like a mainframe computer. But like any computer, the more memory or the primary memory that you have, the better your computer will function. Now, in today's age, um, you can say that the default standard to ensure that your computer can work efficiently is 8 gigabytes of RAM. And even 4 gigabytes is good enough, but if you want your computer to function efficiently to the best, then at least 8 gigabytes should be enough. In the past, when I first got a computer, 2 gigabytes was a lot of RAM. But as the operating system continues to upgrade, as technology advances, it starts to take up more memory, and that's why we need more memory in terms of RAM to carry out our tasks. So 8 gigabyte is about the standard right now. Now, in terms of hard drive, you would mostly see 1 terabyte hard drives. So, but you might still see smaller sizes, maybe a 512, 512 megabyte hard drive, and so on. Now, most computers can contain multiple processors working at speeds of 3 gigahertz. I think we looked at how CPU is measured in terms of processing. So HZ stands for Hertz, and the G, just like the G in our storage sizes, the G stands for gig. So this is 3 gigahertz. The M, which would have been mega, if you had seen an M here, would have been 3 megahertz. Now, it's the same. If the higher the number, the faster the processing of the computer. So, the uses for a desktop computer, it is mainly used for the office, for school work, to play games, for entertainment, looking at videos, browsing the internet, sending emails, and so on. You use it for common everyday tasks. Unlike a desktop, a mainframe, which is used to support thousands of users. So that's what can help you guys to remember the differences between the types of computers if you contrast it between the different types. So our next type of computer is mobile devices. Let's have Keslin.
Mobile devices, also called handheld devices, include laptops, notebooks, netbooks, tablets, smartphones, e-readers, and game consoles. They are similar to personal computers but are smaller, lighter, and contain batteries so that they are not restricted to being connected to electrical outlets.
Good. So did you guys know that your smartphone is considered a computer? Did any of you know
Yes, sir.
that? Well, it actually is because I think we looked at it before in one of our chapters. Your smartphone actually has all of the same components like a normal computer. So the desktop and the laptop, they have the three main components: input, output, and storage. Your smartphone has that also. Um, your smartphone has input, it has a screen where you can touch. Some of your phone may have a keyboard. Um, it has output device, which is the same screen that you can see. It also has a speaker, and for processing, it has a CPU inside of it. So if it's an Apple device, it has an Apple CPU. If it is Android device, it might have some sort of Snapdragon CPU or something of that sort. So mobile devices, laptops, notebooks, netbooks, tablets, smartphone, e-reader, even your game console, they all fall under mobile devices because they are smaller, they are lighter, they have batteries inside so that you can take them around basically. So they're more portable.
Sir,
Yes?
can a smartphone have a PC fan?
PC fan?
Yeah.
Not exactly a PC fan, but they can have fans inside of them if the manufacturer puts it inside. I think there's some phones. There is a phone with a fan inside. I think one of Razer's phone, or is that just the housing? But it can have it inside of it. But just that these um, mobile devices, they actually don't need fans because they're they take up so little power and their processing power is smaller compared to a desktop. So they don't produce as much heat so as to damage the components, and that's why they don't actually need a fan. Because for those of you who have a desktop, if the fan on your CPU stops working, you can actually damage the CPU. But in these mobile devices, we don't have a fan. Some of them, most of them, don't have a fan on their CPU because they don't push enough heat so as to damage the components. And the last one, embedded system. Let's have Kezia.
Embedded system. An embedded system is a dedicated system that is designed for one or two specific functions. These systems are therefore embedded as a part of a complete hardware device called an embedded device. They consume very little processing power and may not be able to connect to the internet. Aim is to increase the reliability and performance of the device. Embedded devices can be found in digital watches, printers, washing machines, banking ATM machines, and even four-wheel drive vehicles with smart installations such as traffic lights. Some embedded devices have no user interface. Others may use simple menu systems or touchscreens.
Good. So these embedded systems, they are still computer systems, but they're only designed for specific function. Maybe to monitor something, or as the examples here show, these embedded systems might be only designed to tell you the time, to print a document, to process documents, to operate a washing machine, to operate the ATM machine, to operate vehicles, traffic lights, and so on. So, embedded systems are designed for a specific task. So, because they only are carrying out one or two or a few specific tasks, that means they have, let's see, very little, they consume very little processing power. So unlike your phone, your mobile devices or your desktop devices, they carry out much more processing as compared to a embedded system. Now, an embedded system may or not be able to connect to the internet. It all depends on the need of that embedded system. If it doesn't need to connect to the internet, then the developer won't add that feature. Now, the main aim of the embedded system is to increase the reliability and performance of the device. So, by designing it only for a specific task, then you can basically master that task. So you can get better and better at doing that task, and thus it is more reliable and it has better performance. If you think about it, your laptop, your desktop, your phone, they do so many things, but at times they may not do it perfectly because there's so much things that the manufacturer has to look at that they cannot focus on all to the best of their ability. You have to wait maybe months or years so that they can actually perfect that device. But an embedded device is only one or few tasks, so it is more reliable and has better performance. So these are some of the examples of embedded systems. Some embedded devices have no user interface. So as I mentioned, it all depends on the need. Um, if you don't need to interact with the system, with the computer system, then there won't be a need for a user interface. But some would have a simple menu or a touchscreen so that you can maybe change a few settings so that it can operate based on different situations and so on. So that is all of the computer systems that we will be looking at today. So in review, today we looked at the types of computers for different situations, for different tasks. We would have different computers for different needs. And we looked at 1, 2, 3 to 4 types of computers that are used based on different situations. So the mainframe computers are large computers. It has large components, RAM, memory, storage, and so on to support thousands of users. Contrast that now with a desktop computer. It has smaller RAM, storage, and so on compared to a mainframe because it is only being used by one person at a time. So it doesn't need all of those high components as a mainframe. Now, a mobile device is much smaller and it's more portable, and that's why persons might make use of it because of the portability. And lastly, we looked at embedded systems which have limited tasks, limited functions compared to the mainframe, the desktop, and the mobile devices because it is only being designed for something specific, like controlling a traffic light or controlling your car so that you can see navigation and so on. So this homework here, I think I already posted it in the classroom. You'll complete that on your Google Forms. So that means I will let you guys know about when to create your video because this is actually the last notes that you'll be writing. 1.11 you are printing. So I'll let you know, inform you about what you're doing for that one. So this has brought us to the end of today's class. If you guys don't have any question on today's topic, you are free to leave. Enjoy the rest of the day.